Hello students of class 9. In our previous video we discussed some of the theorems, theorem 9.1 and then example 1, and then this is another example. Actually it should have been a theorem. So in here the first theorem, that is theorem 9.1, one time again I am doing a revision. Theorem 9.1 saying that parallelograms on the same base and between the same parallels are equal in area. Okay, in here there are two parallelograms ABCD and EFCD. These two parallelograms, they are on the same base and they are between the same parallels. Yes, so these two parallelograms will have an equal area. Okay, parallelograms on the same base and between the same parallels are equal in area. Okay, so this one how to prove I have already showed you. Next one, this is an example there. Okay, this is an example, and this is an example given, but it should have been a theorem. It should have been theorem 9.2. If a triangle and a parallelogram are on the same base and between the same parallels, then the area of the triangle is equals to half the area of the parallelogram. Understand this? In here one triangle there and one parallelogram there. Triangle is triangle PAB and the parallelogram is ABCD. Okay, one triangle there and one parallelogram there. These two parallelograms have got the same base and they are between the same parallels. Understand? So according to example 2 here, it is saying that the area of this triangle will be is equals to half the area of this parallelogram. Understand? Look at the parallelogram very carefully. The parallelogram is ABCD, that is your parallelogram, and the triangle is PAB. Okay, this triangle and this parallelogram, they are on the same base and they lie between the same parallels. Understand? So therefore the area of this triangle will be is equals to half the area of this parallelogram. That is, we have already proved it. Okay, now these theorems we will need it because in example 2, okay, we will need these theorems to solve problems in exercise 9.2. okay, so exercise 9.2, question number 1, in figure 9.15, ABCD is a parallelogram. Yes, ABCD is a parallelogram. Now AE is perpendicular to DC, AE is perpendicular to DC, and CF is perpendicular to AD. CF is perpendicular to AD. This AB value given, AE value given, CF value given, I have to find AD. AD value I have to find. Okay, so very easy there. First of all, you see this is your exercise 9.2. So in here you see, first of all I will write given ABCD is a parallelogram. Yes, ABCD is a parallelogram. AE is perpendicular to DC, CF is perpendicular to AD, AB is equal to 16 centimeter, AE is equals to 8 centimeter, CF is equals to 10 centimeter. I have to find AD here. Okay, I have to find AD. So now I will do the solution. So this one, you see, this is the parallelogram. ABCD is the parallelogram. Yes. Now to find the area of a parallelogram, we know the formula. It is base into height. Yes. To find the area of a parallelogram, the formula is base into height. Okay. So first of all, I will take this height AE and base DC I will take. So area of this parallelogram ABCD will be is equals to AE into DC. Okay. AE into DC. Understand? Height into base or base into height, whatever you say. Okay, area of parallelogram ABCD, it will be is equals to AE into DC. Finished? So AE into DC, AE value is given, DC value is also given. Understand? AE value, you see your AE value is given, but DC value is not given, but DC will be is equals to AB. Okay, DC will be is equals to AB because ABCD is a parallelogram, and in parallelogram the opposite sides are equal. Yes, opposite sides are equal and parallel. Understand? So if AB is 16 centimeter, then DC will be also 16 centimeter. Understand? So DC value also 16 centimeter. Since AB is equals to DC, opposite sides of a parallelogram are equal. Finished? This one I will keep it in this way. Next, again I will say area of parallelogram ABCD. Okay, area of parallelogram ABCD. This time I will find the area, but what I will do, I will take a different altitude and different base. Okay, I will find a different altitude and different base. This time I will take CF as the altitude and AD as the base. So therefore area of parallelogram ABCD will be is equals to CF into AD. Okay, first what I did, first of all I did that area of parallelogram ABCD, it is equals to AE into DC. Yes, area of parallelogram ABCD, it is equals to AE into DC. Finished. First of all I took AE altitude and DC base. So area of parallelogram ABCD, it is AE into DC. Finished. Values value I gave 8 into 16 I got. I will keep that in like that only. Next again I will write area of parallelogram ABCD. Now I will take a different altitude and different base I will take. Finished. So area of parallelogram ABCD will be is equals to AF into AD. Okay, AF into AD. AF value is given 10 but AD value is not given, so AD will remain AD only. Understand? AD will remain AD only. Now you see what I am doing here. I am finding the area of this parallelogram only. Same parallelogram area only I am finding. Yes or no? But different altitude and base taking. Yes, but whose area I am finding? I am finding the area of this parallelogram ABCD. Okay, first I took AE as the altitude and DC as the base, and next time I took AF as the altitude and AD as the base. But whatever I do answer, it will remain same only because I am finding the area of this parallelogram only. Understand? So therefore I can say that 8 into 16 will be is equals to 10 into AD, because this is what I am doing here. Area of ABCD only I am doing, and area of ABCD. In here you can write area of parallelogram. Area of parallelogram ABCD. Okay, in here also area of parallelogram ABCD. Area of parallelogram ABCD. Okay, with height CF and base AD is equals to CF into AD is equals to 10 into AD. So in here what I am doing, I am finding the area of ABCD only. I am finding the area of ABCD. Just I am taking different height and base. Understand? So whatever the answer I will get the same answer only. Understand? Because I am finding the area of this parallelogram. Yes or no? So therefore I can say that 8 into 16 will be is equals to 10 into AD. Now 8 into 16 will be is equals to 10 into AD. From there AD value I will find, which is 12.8 centimeter is equals to AD. Understand? That much only in here, again nothing there. Okay. Okay, so that much only in here, again you're nothing there. Understand? This one. Okay, area of parallelogram ABCD. First of all, I will take AE as the altitude and DC as the base. So area of parallelogram ABCD will be is equals to AE into DC. Value I will put. Finished. And next again I will write area of parallelogram ABCD, but this time what I will do, I will take different altitude and different base. Okay, which is next time I will take CF into AD. CF value is given but AD value not given. AD value I have to find. So since I am finding the area of the same parallelogram, so therefore this one 8 into 16 will be is equals to 10 into AD, I can say. Understand? And from that AD value I will find out. Okay, that much only, again nothing there. Finished? Okay, same parallelogram area only I will find, but each time I will take different altitude and base, and then both of their areas will be equal. So I will equate them, and from there I will find the value of AD. Understand? That much only, again nothing there. Next one, you see question number 2. If E, F, G and H are respectively the midpoints of the sides of a parallelogram ABCD, so that area of EFGH is equals to half area ABCD. Okay, if E, F, G and H are respectively the midpoints of the sides of a parallelogram ABCD, so that area of EFGH is equals to half area ABCD. This is your writing style. Okay, AR ABCD, that means area of ABCD. Okay, so in here question number 2, you see this will be your diagram. Okay, question number 2, this will be your diagram. So in here ABCD is a parallelogram. Okay, ABCD is a parallelogram, and EFGH are respectively the midpoints of AB, BC, CD, DA. Understand? These points are midpoints of these sides. Okay, that is our given. I have to prove that. What I have to prove here? I have to prove that area of EFGH, is equals to half area of ABCD. Okay, area of EFGH is equals to half area of ABCD. That one I have to prove here. Okay, so in here one construction I will do, join GE. This GE I will join it. Understand? GE I will join it. Okay, finished. So in here this join GE, this GE I will join it. Okay, question number 2, from the beginning I am saying in here ABCD is a parallelogram. Yes, ABCD is a parallelogram. Okay, and EFGH are the midpoints of sides AB, BC, CD and DA. Okay, I have to prove that area of EFGH is equals to half area ABCD. So in here I will do a small construction. This is join GE I will do. Finished, and then I will start the proof. Okay, so in here you see, since DC is parallel to AB, since ABCD is a parallelogram, yes, DC is parallel to AB, this one you see here, DC will be parallel to AB since ABCD is a parallelogram. So since I have said that DC is parallel to AB, so I can say that DG is parallel to AE because G and E are the midpoints of DC and AB. Understand? Therefore I can say that DG is parallel to AE. Okay, one time again I am saying, you see, DC is parallel to AB because ABCD is a parallelogram, and in parallelogram we know that opposite sides are parallel and equal. So since ABCD is a parallelogram, so therefore in here DC parallel to AB I can say. Now DC parallel to AB, so now I can say that DG is parallel to AE because G and E are the midpoints of DC and AB. So therefore since DC is parallel to AB, so I can say that DG is parallel to AE. Okay, finished. Next you see, next I have said that DC is equals to AB since ABCD is a parallelogram. DC is equals to AB. First I say that DC is parallel to AB. Now I am saying DC is equals to AB. DC is equals to AB because ABCD is a parallelogram. Opposite sides are equal and parallel. First of all I say that DC is parallel to AB. Next I am saying that DC is equal to AB. So since DC is equals to AB, so DC how I can write? DC I can write as twice DG because G is the midpoint of DC. So therefore instead of writing DC I can write twice DG, and instead of writing AB I can write twice AE. So therefore next what I can write? Twice DG equals to twice AE. That one only I have written here. Twice DG equals to twice AE since G and E are the midpoints of DC and AB. Now 2 cut, ultimately I will get DG equals to AE. Yes, ultimately what I saw, DG equals to AE. So in here what I saw? In here I saw that DG is parallel to AE and DG is equals to AE. Understand? Opposite sides equal and parallel I saw. Yes, so therefore now I can say that AEGD is a parallelogram. Okay, this portion. AEGD is a parallelogram. Finished? AEGD is a parallelogram. Okay, so now in here you see, since I have showed, that AEGD is a parallelogram. Yes, this one you see, AEGD, this small portion, AEGD is a parallelogram. Since I have showed, now you see in this parallelogram, if you look nicely in this parallelogram, you see there is a triangle which is EHG. This is a triangle, this triangle and this parallelogram AEGD. Yes, this triangle, there is a triangle and there is a parallelogram, you see. This triangle and this parallelogram, they have got the same base and they lie between the same parallels. Yes, they have got the same base G and they lie between the same parallels. So therefore I can say that area of this triangle is equals to half the area of this parallelogram AEGD. Look only this portion, okay, look only this portion you look. Understand? This portion you see. This is a parallelogram. AEGD is a parallelogram, and in this parallelogram there is a triangle EHG is a triangle. And this triangle and the parallelogram, they have the same base and they lie between the same parallels. So therefore I can say that area of this triangle is equals to half the area of this parallelogram. That one only I have done. Okay, that one only in here I have done. This is, you see, area of triangle GHE is equals to half area of AEGD. Now in here there is a bracket. Now in here there is a bracket. In the bracket what you will have to write? You will have to write, you see, this is example 2. What it is given in example 2. But you will write it in this way, you see. If a triangle and a parallelogram are on the same base and between the same parallels, okay, and between the same parallels, then prove that, this is no need to write, you will write in this way. If a triangle and a parallelogram are on the same base and between the same parallels, then the area of the triangle is equal to half the area of the parallelogram. This much you will have to write it down in this bracket. Okay, if a triangle and a parallelogram are on the same base and between the same parallels, then the area of the triangle is equals to half the area of the parallelogram. This one you will have to write it in here, and this will be equation number 1. Similarly, I can say that this time I will take the next part. Okay, BEGC is a parallelogram. Okay, I will show you. BEGC is a parallelogram. Therefore, area of triangle EFG is equals to half area of EBCG. Okay, EBCG, and in here also you will have to write the same thing. If a triangle and a parallelogram are on the same base and between the same parallels, then the area of the triangle is half the area of the parallelogram, and this will be your equation number 2. Now equation 1 plus 2 if I do, then I will get area of triangle GHE plus area of triangle EFG is equals to half. I can take out common. Yes, half both only there. I can take out common. So I will get area of AEGD plus area of EBCG. This one I will get. So area of triangle GHE plus area of triangle EFG. This I will get area of EFGH, and this will be is equals to half area of AEGD plus area of EBCG. It will become area of ABCD. Understand? This is our proved. Now I will show you according to the diagram. You see, one time again I am showing. This is, now you see, ABCD is a parallelogram. Okay, look very carefully. ABCD is a parallelogram. Okay, and EFGH are the midpoints of AB, BC, CD and DA. Finished. I have to prove that area of EFGH is equals to half area of ABCD. Finished. Now I will do a construction. In here I will join GE. Okay, I will join in here GE. Then what I will do, you see, I will say that DC is parallel to AB because ABCD is a parallelogram. So opposite sides are equal and parallel. So therefore ABCD is a parallelogram. So now, DC is parallel to AB. Okay, DC is parallel to AB since ABCD is a parallelogram. Okay. Now, since I have said that DC is parallel to AB, so now I can say that DG is parallel to AE. Okay, I can say that DG is parallel to AE. Finished, because G and E are the midpoints of AB and DC. So therefore, since DC is parallel to AB, so I can say that DG is parallel to AE. Finished. Again, next I will say that DC is equals to AB, because again in a parallelogram opposite sides are equal and parallel. So therefore I can say that DC is equals to AB. Okay, since ABCD is a parallelogram. Now, next DC is equals to AB. Next I can write that twice DG equals to twice AE. Twice DG equals to twice AE. Instead of writing DC, I can write twice DG. And instead of writing AB, I can write twice AE. Instead of writing AB, I can write twice AE. Because G and E are the midpoints of DC and AB. Now 2 cut, and ultimately I will get that DG is equals to AE. Yes, ultimately I will get that DG is equals to AE. So therefore now I can say that AEGD is a parallelogram. Understand? AEGD is a parallelogram. Because opposite sides, I have showed that opposite sides are parallel and equal. So therefore AEGD is a parallelogram. Now if you look here, in this parallelogram there is a triangle also. This triangle and this parallelogram, they shares the same base. Yes. So therefore I can say that area of triangle EHG is equals to half area of AEGD, because I know that a triangle and a parallelogram, I know that if a triangle and a parallelogram are on the same base and between the same parallels, then the area of the triangle will be equals to half area of the parallelogram. Done? That one I will write equation 1. And similarly, I will come to this portion now. Okay, similarly, I can say that area of triangle EFG is equals to half area of this parallelogram, EBCG. Okay, EBCG, this parallelogram. Because again I will write, if a triangle and a parallelogram are on the same base and between the same parallels, then the area of the triangle is equals to half the area of this parallelogram. That will be our equation 2. Equation 1 plus 2 if I do, then I will get that area of this triangle plus area of this triangle is equals to half will come out common area of this parallelogram plus area of this parallelogram. Understand? So ultimately I will get area of this triangle plus area of this triangle, I will get area of this whole quadrilateral EFGH. Yes or no? I will get the area of this whole quadrilateral. So area of EFGH will be is equals to area of this parallelogram plus area of this parallelogram. Yes, I will get the area of this whole parallelogram. So ultimately I will get that area of EFGH is equals to half area of ABCD. That one only our proved. Again nothing there. Understand? I hope you have understood. Next I will go to question number 3. Next you see question number 3. P and Q are any two points lying on the sides DC and AD respectively of a parallelogram ABCD, so that area of APB is equals to area of BQC. So question number 3, this will be your diagram. Okay, in here you see ABCD is a parallelogram given. Okay, and P and Q are 2 points lying on sides DC and AD respectively. I have to show that area of APB is equals to area of BQC. This one I have to show. Okay, ABCD is a parallelogram given. P and Q are the points on the side DC and AD. Okay, I have to show that area of triangle APB is equals to area of triangle BQC. So in here, first of all, I will write given ABCD is a parallelogram. P and Q are the points on DC and AD. To prove that area of APB is equals to area of BQC, so I will start the proof. So in here you see this triangle PAB, triangle PAB, and this whole parallelogram you take. This triangle PAB and this whole parallelogram, they are on the same base and they lie between the same parallels. So therefore I can say that area of this triangle is equals to half the area of this whole triangle. That only I have done here. Area of APB is equals to half area ABCD. In the square you will write that if a triangle and a parallelogram are on the same base and between the same parallels, okay, then the area of the triangle is equals to half the area of the parallelogram. That one you will have to write it in here. And this is equation 1. Next again you see this triangle BQC. Okay, this triangle BQC and this parallelogram ABCD, they lie on the same base. Okay, they are on the same base and lie between the same parallels. Understand? They are on the same base and they both lie between the same parallels. Understand? So therefore I can say that area of triangle BQC is equals to half area of this parallelogram. Understand? Area of BQC is equals to half area of ABCD. Again in the bracket I will have to write, if a triangle and a parallelogram are on the same base and between the same parallels, then the area of the triangle is equals to half the area of the parallelogram, and this will be equation 2. From 1 and 2 what do I get? You see this one, you see right hand side equal there, half area ABCD, half area ABCD, right hand side equal, so left hand side equal I can say. That is only our proved. Understand? One time again I am saying this is P and Q are points on the sides DC and AD of this parallelogram ABCD. I have to prove that area of this triangle is equals to area of this triangle. So first of all I will take in proof I will write area of triangle PAB is equals to half area of this whole parallelogram, because I know that if a triangle and a parallelogram are on the same base and lie between the same parallels, okay, then the area of the triangle is half the area of this parallelogram. Okay, and next I will take this triangle, okay, triangle BQC. Again I will write area of triangle BQC is equals to half area of this parallelogram, because I know that if a triangle and a parallelogram are on the same base and between the same parallels, then the area of the triangle is half the area of the parallelogram. Understand? And that will be our equation number 2. Okay, the notes are already given, you one time check it. Understand? And from equation 1 and 2, you see right hand side equal, I am getting right hand side equal, so therefore I can say that left hand side equal. Next I will go to question number 4. In figure 9.16, P is a point in the interior of the parallelogram ABCD, so that area of APB plus area of PCD is equals to half area ABCD. This is your diagram given. Understand? In here there are two proofs here. So first of all, you see this is our diagram. Okay, this is our diagram. ABCD is a parallelogram, and then P is a point in the interior of this parallelogram. I have to prove that area of APB plus area of PCD, area of this triangle, the above triangle, plus area of this below triangle PCD is equals to half area of this whole parallelogram ABCD. That one I have to prove here. So first of all I will write given that ABCD is a parallelogram. Yes, ABCD is a parallelogram, and one thing I can write that P is a point in the interior. P is a point in the interior of parallelogram ABCD. P is a point in the interior of parallelogram ABCD. Okay, P is a point in the interior of parallelogram ABCD. To prove that, first proof I have to do area of APB plus area of PCD is equals to half area ABCD, and next one I have to prove area of APB plus area of PCB is equals to half area APB plus PCD. Okay, this one I will have to prove here. Let me do one thing here. This one second proof, no need to write, because for type 2, okay, for type 2 again I have drawn the diagram. Okay, in there is a different construction. Again I have drawn the diagram and given, and to prove that I have written here. So in here 2 times, no need to write. The second proof one I will cut it. Okay, this one I will cut it. First of all I will write number 1. Okay, that is I have to prove that area of triangle APB plus area of PCD is equals to half area ABCD. This is I have to prove here. Finished. So now I will do a construction. What I will do, a line is drawn through P, parallel to DC, which intersects AD at E and BC at F. Okay, a line is drawn through P, parallel to DC, okay, which intersects AD at D and BC at F. Understand? This one you will have to, this sentence you will have to remember. A line, okay, a line is drawn through P parallel to DC, which intersects AD at D and BC at F. Okay, now I have to prove what I have to prove here. Yes, I have to prove that area of APB plus area of PCD, these two triangles area plus, if I do, then it will be is equals to half the area of this whole parallelogram. So first of all, in here I will write that DC is parallel to EF. This is from construction. Understand? DC is parallel to EF. This is from where I will get, from construction I will get. Understand? So DC is parallel to EF, okay, and then next AD is parallel to BC. Okay, first of all I will say that DC is parallel to EF and AD is parallel to BC. AD is parallel to BC. Why? Because ABCD is a parallelogram. Yes, AD is parallel to BC. Why? Because ABCD is a parallelogram. Understand? So since AD is parallel to BC, so now I can say that DE is parallel to CF. Okay, DE is because this line is parallel to this line, then of course this line will be parallel to this line. Yes, DE is parallel to CF. Understand? So therefore I can say that DCFE is a parallelogram. This side, DCFE is a parallelogram. Understand how I have showed DCFE is a parallelogram? First of all, I have said that DC is parallel to EF. This is I will get from construction. Next, I can write that AD is parallel to BC because ABCD is a parallelogram. So since AD is parallel to BC, so I can say that DE is parallel to CF. Yes, DE is parallel to CF. So what I showed here, I showed that DC is parallel to EF and DE is parallel to CF. Opposite sides are parallel, I showed. Yes or no? Opposite sides are parallel, I showed. So therefore I can say that DCFE is a parallelogram. Finished? DCFE is a parallelogram. So now you see there is a triangle. There is a triangle inside this parallelogram, and this triangle and the parallelogram are on the same base and between the same parallels. Yes, so therefore I can say that area of this triangle PCD, area of this triangle PCD, it will be is equals to half area of this parallelogram DCFE. Understand? Area of this triangle PCD, okay, PCD or PDC, whatever you say, area of this triangle will be is equals to half the area of this parallelogram DCFE. Finished? That will be our equation number 1. And in the bracket I will write that if a triangle and a parallelogram are on the same base and between the same parallels, then the area of the triangle is half the area of the parallelogram. Finished? And similarly I will say the top part one, similarly I will say that area of this triangle APB, area of this triangle APB will be is equals to half area of this parallelogram AB. This is ABFE. Okay, ABFE. Understand? Area of this triangle will be is equals to half area of this triangle, area of this parallelogram ABFE. Finished? Again, I will write that if a triangle and a parallelogram are on the same base and between the same parallels, then the area of the triangle is half the area of the parallelogram. That will be our equation number 1. Equation 1 plus 2 if I do, then what I will get? In the left hand side, I will get area of this triangle plus area of this triangle is equals to right hand side half. I will take out common. I will get area of this parallelogram this is parallelogram EFCD, okay, or DCFE, whatever you say. Okay, half will come common. Okay, half bracket start area of DCFE plus area of the above parallelogram, which is ABFE. Understand? So left hand side area of this triangle plus area of this triangle, it will remain in that way only. Area of PCD, okay, area of PCD plus area of APB will be is equals to half area of this down parallelogram and this up parallelogram. Both of this area, if you add it, you will get this area of this whole parallelogram. So ultimately you will get area of APB plus area of PCD is equals to half area of ABCD. This is our proof. Again, to prove the second one, again this same diagram only I will draw, but this time construction I will do in this way. Understand? A line is drawn through P, a line is drawn through P parallel to AD. Okay, a line is drawn through P parallel to AD, which intersects AB at R and DC at S. Finished? So this is the diagram. Again, ABCD, same diagram only in a just construction. This is in this way I have done the construction, which is parallel to DC, and next time I will do the construction in this way, which will be parallel to AD. Okay, so in here again I will write given ABCD is a parallelogram, okay, and then P is a point in the interior of parallelogram. P is a point in the interior of parallelogram ABCD. Finished? To prove that, what I have to prove here, area of APD plus area of PBC is equals to area of APB plus area PCD. This is I have to prove here. Finish? That is area of, you see, APD, area of APD plus area of PBC is equals to area of APB plus area of PCD. Understand? That one I have to prove here. Now construction I will do. A line is drawn through P, parallel to AD, which intersects AB at R and DC at S. Finished. Okay, now I will say, you see, AD is parallel to RS. This is I will get from construction. Yes, AD is parallel to RS. This is I will get from construction. Finished. AB is parallel to RS, and next I will say that AD, okay, AD parallel to RS. This is from construction I will get, and next I will say that AB is parallel to DC since ABCD is a parallelogram. Okay, AB is parallel to DC since ABCD is a parallelogram. Okay, now AB is parallel to DC, so now I can say that AR is parallel to DS. Yes, AR is parallel to DS. Okay, AB is parallel to DC, so therefore I can say that AR is parallel to DS. Okay, finished. AR is parallel to DS. Now I can say that ADSR is a parallelogram. This side you see, ADSR is a parallelogram because opposite sides, ADSR is a parallelogram. Opposite sides parallel I have showed, so therefore the quadrilateral I can say that it is a parallelogram. Finished. Now in this parallelogram you see there is a triangle PAD. There is a triangle. Okay, this triangle and this parallelogram, they are on the same base. Okay, and they lie between the same parallels. Yes, so therefore I can say that area of this triangle, which is PAD, area of PAD is equals to half area of, I can say, ADSR. Okay, area of this triangle is equals to half area ADSR. Again in the bracket I will write, if a triangle and a parallelogram are on the same base and between the same parallels, then the when a triangle and a parallelogram are on the same base, okay, if a triangle and a parallelogram are on the same base and between the same parallels, then the area of the triangle is equals to half the area of the parallelogram. This one I will write. And similarly in the next part also I can say that area of BPC is equals to half area of this parallelogram RBCS. Okay, or how I have named it in here, RSCB. Okay, RSCB. Understand? Area of BPC is equals to half area of RSCB. Finished. Again I will have to write in the bracket that if a triangle and a parallelogram are on the same base and between the same parallels, then the area of the triangle is half the area of the parallelogram. That will be equation number 2. Finished. This is our equation 2 and this will be equation number this will be equation 1 and this will be equation number 2. Okay, now 1 plus 2 if I do, then I will get area of APD plus area of PBC is equals to half, it will be common, area of ADSR plus area of RSCB. Now area of ADSR plus area of RSCB, I will get area ABCD. Understand? Because this is one parallelogram and this is one parallelogram. Both if I add, then I will get the area of this whole parallelogram. Yes or no? And this will be our equation number 3. After adding, this will be our equation number 3. Understand? Now you see this is one equation I am getting, and this is I have already proved it. Area of APB plus area of PCD is equals to half area ABCD. This is already I have proved it. Now this equation, and if you see this equation, these two equation, if you compare it, this one I will write it again. This is already proved because I have already proved it in number first one I have already proved it. So this one I will give equation 4, and just now that I have proved this is equation 3. From 3 and 4 what do I get? You see right hand side equal there, so left hand side equal I can say. So therefore from equation 3 and 4, area of APD plus area of PBC is equals to area of APB plus area PCD, and this is our proved. Understand? That much only. Again nothing there. Next I will go to question number 5. Question number 5 in here saying in figure 9.17, PQRS and ABRS are parallelograms and X is any point on the side BR, so that area of PQRS equals to area of ABRS, and next I have to show that area of AXS is equals to half area PQRS. Okay, this is I have to solve. So this one you see question number 5. In here PQRS, okay, PQRS and ABRS, okay, PQRS and ABRS, these two are parallelograms, and X is any point on side BR. X is any point on side BR. I have to show that area of PQRS is equals to area of ABRS. Okay. In our earlier, the note that I have given you, I think at first this triangle I have not drawn, because in order to prove the first proof, I do not need this triangle. Okay. And again, to prove the second one, okay, that is this one, area of AXS is equals to half area, then I will need this triangle. So one thing I can do is that first I can draw these two triangles, okay, and not draw this, first I can draw these two parallelograms and not draw this triangle, okay, to prove the first one, that is this one. When I will prove the next one, then again I will have to draw the diagram and then I will draw the triangle. In that way also I can do, or in here what I have done, in one diagram only, this one I have drawn it. Okay, so this is given ABRS and PQRS are two parallelograms, and next in here one X is any point on side BR. Okay, X is any point on side BR. To prove that, area of PQRS is equals to area of ABRS, and next area of AXS is equals to half area PQRS. So first I will do the proof. This is first one I am doing proof. Okay, first one. So in here you see I can say that AS is parallel to BR. Okay, AS is parallel to BR because ABRS, okay, ABRS is a parallelogram. So therefore AS is parallel to BR, I can say. Finished. And next you see angle PAS, okay, angle PAS is equals to angle QBR. This angle will be equals to this angle. Okay, because they are corresponding angles. Yes, this angle will be equals to this angle. This is parallel to this. Okay, this is parallel to this, and PB is the transversal. So therefore this angle will be equals to this angle. Understand? Corresponding angles. Next again I can say that PS is parallel to QR. Okay, PS is parallel to QR because PQRS is a parallelogram. Okay, PQRS is a parallelogram. So therefore PS is parallel to QR, I can say. Finished? So therefore I can say that now this angle will be equals to this angle. Okay, angle SPA is equals to angle BQR. Okay, SPA is equals to angle BQR. Finished? Again corresponding angles. And next I can say that AS is equals to BR. Okay, AS is equals to BR since ABRS is a parallelogram. Parallelogram opposite sides are equal and parallel. So therefore AS is equals to BR, I can say. Finished? So now you see this triangle PAS will be congruent to triangle QBR. Okay, triangle PAS will be congruent to triangle QBR. Understand? By AAS congruency. Okay, by AAS congruency. So since these two triangles, okay, these two triangles are congruent, therefore their areas will be equal. So therefore I can say that area of PAS is equals to area of QBR. Finished? Okay, so now in here you see area of what I got, area of triangle PAS equals to area of QBR. These two triangles area equal I got. Now with these two triangles, this area both side I will add it. ABRS, area of ABRS I will add it both side. Both left hand side, this is equal I got now, and both left hand side and right hand side area AQRS I will add it. Now area of PAS plus area of AQRS, area of PAS, that is this triangle area, plus AQRS, this much area, this I will get area, this whole parallelogram area I will get, PQRS, this whole parallelogram area I will get, and is equals to, in the right hand side again, area of this triangle plus area of this portion AQRS, I will get area of ABRS, this whole parallelogram area I will get. Understand? This triangle area plus this much area, this whole parallelogram area I will get. So ultimately I got this is area of PQRS is equals to area of ABRS. This is our first one proof. Now next one I will prove to. Okay, now I will write the next one. Now next one you see in here, area, I can say that area AXS is equals to half area ABRS. Okay, area of AXS, you see in this parallelogram ABRS, okay, in this parallelogram ABRS and this triangle AXS, this triangle and this parallelogram, they both share the same base. Okay, they are on the same base and lie between the same parallels. Yes, so therefore I can say that area of AXS is equals to half area of this parallelogram ABRS. Okay, area of AXS is equals to half area of ABRS. In the bracket I will write, if a triangle and a parallelogram are on the same base and between the same parallels, then the area of the triangle is equals to half the area of the parallelogram. Understand? That one I will write it down. Finished. And what I have to prove? I have to prove that in here area of AXS is equals to half area PQRS. And what I have got? Area of AXS is equals to half area of ABRS I got. Okay, ABRS. I have to prove area of PXS is equals to half area PQRS. This parallelogram half I have to prove, but I have got this parallelogram half. Understand? So next line directly I can say that area of AXS is equals to half area of PQRS, because from the here I can say that area of PQRS is equals to area of ABRS. Yes or no? So therefore instead of writing half area ABRS, this is, you see, this is area of PQRS is equals to area of ABRS. Okay, and this is already proved. Okay, this is already I have proved, and this will be equation number 2. Understand? This is equation 1 and this will be equation number 2. This is already proved. That one only, the first proof one, that one only I have done here. Yes or no? So now instead of writing this is area of AXS is equals to half area ABRS. Now instead of writing ABRS, since area of ABRS is equals to area of PQRS, so therefore I can write area of AXS is equals to half area PQRS. Understand? This is our proved. So that much only in here. Again nothing there. With this your chapter 9 it is over. Another one question is there, question number 6. This is, we will discuss it later. Okay, question number 6 we will discuss it later. So in this video we have, you see, I gave 2 videos from chapter 9, areas of parallelograms and triangles. I have given 2 videos. In the first video we discussed some of the theorems and example, and in the second video we discuss exercise 9.2. Yes, we discuss exercise 9.2. So with this our chapter 9 is over. Okay, our chapter 9 is over. So next what you will do, you look at this video very carefully, both the videos you look very carefully, and then exercise 9.2 you will have to submit as a homework. Okay, you first of all exercise 9.2 you write it, understand, and then you will have to make an audio where you will explain each of these sums. Question number 6 no need, because question number 6 we have not discussed it. I hope you have understood. So with this our chapter 9 areas of parallelograms and triangles it is over. Next we will go to circles. We will go, okay, next we will go to circles. I hope you have understood. Thank you.